Okay, I'm Theo. I'm from Göteborg. I'm the chief architect at a Göteborg company called Burt. I also run the Göteborg equivalent to this meetup group, and actually started it because this one started about a year ago. It was announced on meetup.com, and I thought we need something like this in Gothenburg, so I started that. And we've been running for about a year, so I'm really happy that you guys have finally gotten around to doing something yourselves. Who here has heard of Burt before? There are a few. Awesome. I don't really know if people up here have actually heard of us. Since we're based in Gothenburg and we do enterprise software, people might not have heard of us before. But we do business intelligence for digital publishers. So we basically explain to publishers what they make money of on the internet. You thought they didn't know, but they don't. This is our architecture. This is my sketch to prove I'm an architect. I'll get back. I think I'm cutting out, sorry. Okay, thanks. So I'll get back to this sketch throughout the presentation. So even though maybe not all of these things are immediately clear to you, we'll go through them. But before I do that, I want to explain sort of the things that go into the back end and the things that go out, so that we have a context around what we do and sort of what is Burt's data processing platform actually doing. And as I said, we work with digital publishers. They have websites, lots and lots of websites. If you've been on the internet and been on a Swedish site or a Norwegian site or maybe a German site or a Dutch site, it's a good chance that we have tracked your page views and kind of know what you've been doing. But it all starts with a page view, and I mean, this is basically everyone here has probably written some piece of code that does web analytics for their own blog or for whatever, and you can get loads of these tools for free. And Google Analytics is obviously the most known of them. But so we do that. But then we also look at the things on the page view. So, for example, ads. That's the main thing that we track besides the page view. We also track things like, well, basically any square thing on a web page we can track, but usually that means ads. And the tracks on this slide sort of show that ads can they don't all load at the same time as the page. Some of them are slower because of a slow ad server, or some of them may be actually added by the page later on. So we discover the ads and we start tracking them, and we want to know, are they visible or not? So we look at what's in screen right now, and we aggregate the visible duration for every ad. So let's say that the red portions of the tracks here are the durations when these ads were visible, and the gray areas is when it was not in screen. But then we also want to know, was this a quality page view or not? Was the visitor who looked at the page and read the article, were they active, or was this just someone who'd left the computer running and went to lunch? And you would be really, really scared to know the number of page views served where there's actually not a human around to look at the page, and the amount of advertising being paid for that no one actually has any chance of ever seeing. But we don't stop there, so we also track lots of different events going on with these ads and other content. We pick up lots of metadata about the page view, the content, things like who wrote the article, what category on the page are we in, what campaign ID was this ad registered under, things like that. So there's lots and lots and lots of things that we track. So going back to here, we sort of covered the event stream portion at the entry point, sort of to the processing there. There's lots and lots of different events. So when a page view starts, that's an event. When we discover an ad, that's an event. When we discovered, and actually we don't only discover if an ad, we discover the placement where publishers usually put an ad, but sometimes that's also empty. And that is interesting to know. How often do they fill the placements, for example? What is the how good are their sales department? So those are ads. An ad becomes visible. Someone hoovers over the ad. Someone clicks on the ad, and so on. All of that are events. Then we have sort of integrations going on from below. All the IDs and metadata that we picked up on the page. Usually we can't get the campaign name, for example. We only get the campaign ID. So we import all that metadata, the sort of the concrete versions of the metadata offline. And when I say offline, that's sort of in the new world of things. Offline sort of means it's not done in real time. It's more batch oriented, because all of this is actually just one big stream processing platform. We continuously take in events, we process them, and we pass them along downstream and process them more. So in the other end, and I'm purposely skipping the whole middle section, which we're going to talk about a little bit more later. In the other end, we want to explain what the hell is going on to our customers. And we do that through web applications, obviously. We've historically been very focused on reporting and analytics, basically tables, graphs, that kind of thing, which is, for example, this application that's very close to what you'd expect from a site analytics tool, but with some added features like looking at the duration, activity, and sort of what people are doing, instead of the dumb version of site analytics, which is just pages loaded. Did they come from Facebook or not? We want to tell you, yeah, people came from Facebook, and when they come from Facebook, they're worth twice as much to you than if they come from Google, for example. That might not be true, but it might be true for some publishers, and that is something that a publisher really needs to know. But then there's also applications that deal with, not with just analytics, but with, we do lots and lots of indexing of all these page views and try to do models to show where, given what we know about the visitors and the visitors on that website, can we find some kind of model that will help you understand how to best plan a campaign, or to give you data so that you can sell to a specific customer or an advertiser, so that you can tell them if your target audience are females in the age group 25 to 40, you should buy this package, because that will give you the best bang for the buck, and have the data to prove it. So back to the diagram again, and now we're going to sort of dive a bit more into the middle section. Not very much exactly what's going on, but I want to keep it on sort of a philosophical level, on the things, the reasons. The reasons for things being the way they are, and sort of what I've learned by making stupid mistakes during the last 2 years. So, as I mentioned, this is a stream processing system. It never stops. It just takes in new data, it transforms it, and it passes along, and other pieces of it transforms it further, and then eventually it's presented in different applications that show different views of that data, different analyses of that data. And the key piece of it is the one we got here called session assembly, because as I showed you, a page view is just a collection of lots and lots of events. They they are collected over time, and not until we've gotten the last one, we can actually say something interesting about that page view. Until we have the last one, we have no idea, for example, how long was the page view, just something simple like that. And until it's ended, we might not even know how many ads were displayed on that page. So that piece is sort of tracking in real time all of the sessions that are going on right now. So it's keeping track and collecting all of the new events, and then checking them to see has this session ended or not. And anyone who's tried to do something with web pages and trying to do something when a page view ends know exactly how difficult that particular problem is. There's basically an infinite number of ways that a page view can end. You have no reliable way of knowing. If I'm on a web page and just close the lid on my laptop, has that page view ended? Or if I just move to another room and open the lid again, is that page still the same page view? Lots of difficult questions like that. And that component sort of takes care of most of that. And the philosophy behind the whole stream processing platform is one of the central things is just keeping it real time and keeping it streaming. We did have a Hadoop-based analytics engine once upon a time, and I hated every day of that. Not because of Hadoop itself. I mean, people probably laughed a bit because you thought I hated it because of Hadoop, and Hadoop is a monster. But just because of the way of running code in batch systems, it's just you have to wait until all of the interesting things have happened, and then you put them into your batch processing system, and then you have to wait some more, and then you get some results, and it just feels I'm impatient. I don't want to wait, and when it fails halfway through, I have to wait again. And I don't like that model of computation. We do use Hadoop a bit for let's call it prototyping. If we have huge data sets for our customers' data from the last few months, so we can actually prototype a new application that can show that a salesperson can go to the customer and show, would you like this application? And show them the application, a mock-up of the application or a prototype of the application with their data from the last few months in. And that is really, really powerful. But it's more of a prototyping tool. We also try to avoid sort of the thing about sticking things into databases. That's one thing I definitely did in the beginning. Felt databases are meant to put data in. It says so in the name, so we need databases and put data in them. But I've tried to avoid that now and try to find places where you needlessly put data on disk and then just bring it out again and just to pass it on. So instead, keeping it streaming, if you need something that you can't actually handle all of you can't scale to do peaks, for example, then have built-in buffers in your system. Buffers are not the same as databases. Buffers can be message queues, for example, that will take the load and even out peaks and troughs. So all of the system is built around buffers between layers in form of message queues. We use RabbitMQ, which is an absolutely fantastic piece of software, and we don't use it for anything that it's good for, unfortunately. I really wish that we could, but we basically just push data downstream, and RabbitMQ does that well enough. But that is not what it's meant to do. It's meant to do much more about messaging. And we're definitely looking at other ways of doing that more efficiently, because the ways that we do things in RabbitMQ is not how they meant it to be. Another thing that I've learned the hard way is to avoid complecting processing and storage. So if you have data that will be when data at rest, so data that you're not actually actively processing, that should not be on the same node as the node doing the processing, because that means you can't scale those two things individually. If you have data at rest, that will have very, very different scaling properties from data in motion, and which is sort of what processing is. So think about sort of how you design your system, and that sort of goes with a lot of things. If they have different scaling properties, then they should definitely go into different layers or different systems. We've had services in our platform that that just should be one process or multiple processes divided horizontally, but because there are two sub-processes in them that have different scaling properties, we actually split them in the middle vertically and moved parts of it down and put a message queue between them, just so that we can scale both individually and maybe auto-scale one of them, and because the other one can't auto-scale for some reason. So dividing things, and that's like a motto that I've actually learned from the guys here at Spotify, that you decouple until it hurts, and then maybe you back off a bit. That is really, really good advice. Decouple until it hurts, because you will probably get very good things out of that, especially if things are big. And you need to start with two of everything. And if you guys had, if I'd met you before you did your general DB, this is the advice I would have given. Do not start with a database that has only one write master. You need to start with two of everything, so you have tackled that problem first. And I've done this mistake so many times that I almost engraved it in a plaque and put it up on the office. Start with two of everything. Every new guy that comes to us gets this beaten into them. Never ever build something to run on only one machine. You need to run it on two, even if it's stupid and if it's costly to have two machines running, because this thing isn't getting any requests at all. You need to have it on two, because otherwise we have no idea what to do when we need to scale up. And the last advice is maybe the most contentious. Production is the only real test environment. And I don't mean that you should log on to your FTP service and hack your code in production. What I mean by this is that you can have an awesome test suite, and you can have really, really good integration tests, and you can have a QA department that's bigger than my company, but I still wouldn't trust your software until it has run through production data. I wouldn't trust it to perform, and I definitely wouldn't trust it not to blow up when strange things happen. Because if you connect it to the internet, strange things happen every day. And if you have lots and lots and lots of traffic, strange things happen very, very frequently. Back to this sketch again, but there's actually another view of the architecture that I wrote a program that just bounced between all of our servers. It's logged into one of them, checked which other servers had TCP connections open to, then bounced over to those and did the same thing over and over again, and sort of auto discovered the topology of the network, and then it. Then I color-coded the nodes just based on sort of the service name. I didn't have that many colors, so some of the colors are reused. So this is one view of what we do. That's a stream processing system written in Ruby, running on EC2. And there's lots and lots of things going on. I would be very impressed if anyone could identify sort of what is a database, what kind of database it is from this one. It's possible, but it's not easy. And finally, I'll just do some numbers, because numbers are fun. We track about 500 million page views and ad impressions every day. I don't know how many actual events that would be. It's probably 4 or 5, maybe 6 times as many. So a couple of billion HTTP requests per day, about 30,000 per second at peak time. It's a terabyte of data. We don't process it all of it for everything, but that sort of flows through the system, gets processed, chopped up into bits, aggregated up into other bits, and passed along in different parts of the system. And it's all 15,000 lines of code. As I mentioned, we use Ruby. We're very happy Ruby users. We actually run JRuby, which is Ruby on the JVM. So actually, lots of the things that we're using, lots of the libraries that we're using are actually Java libraries. So it's a bit of a hybrid Java Ruby, but all of our code is Ruby. And thanks a lot for having me and if you're ever in Gothenburg, then give me a call or check out the Göteborg Distributed Meetup group. It would be awesome to have some of you down there as well. Thanks.